Hi there. Today we're starting a new series on how to draw pie charts in SwiftUI. This is part 1 of the series where we will focus on the basics, especially the math behind it and things you should consider when start drawing your own pie charts from scratch. Without any further ado, let's get straight into it. Now assume we don't want to draw the whole pie chart, we just want to draw a piece of pie. How do we do that? We declare a struct piece of pie and make sure it conforms to the shape protocol. As soon as we say it should conform to the shape protocol, Xcode will force us to implement this path function. This path function takes a CG-rect and returns a path. So inside of this path function we can do whatever we want. In this case I just decided to move to the center of the CG-rect that we get passed. So path gives us this handy closure where we can directly access and modify the path, and here I'm simply calling it P and I told it to move to the center of the CG-rect. Now where does the CG-rect come from? Now assume we have a content view. That content view decides to call our piece of pie. It tells it to stroke itself by calling the stroke modifier, but obviously that won't result into anything on the screen because all we did in the path function was move to the center. We're not adding any lines or doing anything with the path yet. But the content view also adds this frame modifier with a width of 300 and a height of 300. Now what this means for piece of pie is that its CG-rect that it gets passed through the path function is also limited by this frame width and height. So if we would move to the middle, it would actually move to the width of 150 and height 150. The content view also decides to add a border with a width of 1, and that's what you're seeing on the left side of the screen right now. So far so good, but let's say we want to draw a line from the center to the bottom right corner. How do we do that? Well, we simply call this function on path that is called addLine, and here we say draw a line to the point at 300 in X and 300 in Y. Now since our frame is bounded to 300 width and 300 height, it just perfectly hits the corner of our frame. Now if you're wondering why Y is positive but we're still going downwards, that's because in iOS the coordinate system starts at the top left corner. It doesn't start at the bottom left corner as most people are used to. Instead, when you go down, the Y coordinate increases, and when you go up, the Y coordinate decreases. That being said, let's take a look at another example. If I would change the Y coordinate to 150, it would go up and we would have a straight line hitting the frame on the right side. Now so far so good, we know how to add a line, but how do we add an arc? Well, that's also very easy. Instead of adding a line, we could simply call the addArc function on the path. This addArc function takes a center, a radius, a start angle, an end angle, and whether it should be clockwise or not. So here I'm telling it to start at the center with a radius of half of the frame's width, and it should start at the degree 0 and end at the degree 90. And as you can see on the left screen, that's already pretty close to what we want. Now it's not completely a piece of pie because there's still this open path on the left side. So how do we close that path? Well, that's also very easy. All we have to do is call close subpath. Now instead of 90 degrees, we could also say draw it until, let's say, 270 degrees. And this would look something like this. Okay, now we know how to draw one piece of pie. But let's say we want to draw multiple pieces of a pie. How do we do that? Well, we do it very similarly, but now instead of just drawing one arc, we draw multiple. But what's important here to notice is as soon as you add the new arc, you have to make sure that the end angle of the previous arc matches with the start angle of the next arc, because you want to start the angle where the previous arc left. And you could do it as many times as you want and build your whole pie chart out of it. So now we know how to draw a pie chart, but there's still a few more issues we have to tackle. One of the issues is labeling the pieces. Now 45 degrees could stand for anything. For example, it could be an asset class like stocks, or it could be something else. In any case, we want some kind of label that can tell the user what this 45-degree piece of pie represents. So let's say we want to name it stocks. Now how do we find out where the x and y coordinate for the stalks label is. Let's start with what we know. We know the radius. The radius is 150. What we also know is the degree. We know that it's a 45-degree angle. We don't know what the x and y coordinate is, but with some basic math we can calculate the x and y coordinate precisely. So how do we do that? For that we have to simply use trigonometry. Some of you may have heard this mnemonic from high school where students try to memorize these rules by using this phrase called SOHCAHTOA, and we're actually using it here as well. In this case we're using the middle one. So basically the cosine of theta is defined as the adjacent over the hypotenuse. Now in this case, actually in all cases, the hypotenuse for us is going to be the radius. Now we always know the hypotenuse, but we do not know what the adjacent is. So the adjacent is going to be our x in this case, the variable we do not know about. Now if we multiply both sides with x, what we get is the formula for the x coordinate. So it is basically the radius times cosine of theta, or in our case 150 times cosine of 45 degrees. So this is how it works for the x coordinate. So how do we calculate the y coordinate? Well, we can do it similarly, but instead of the cosine we're taking the sine of theta, which is defined as the opposite over the hypotenuse. Now in this case the opposite is the y and the hypotenuse is still our radius. So the formula can be formulated as y equaling the radius times sine of theta, and that would be in our case 150 times sine of 45 degrees. Great, now we know how to calculate the x and y coordinate for our stalks label. But let's say we don't want to position our label where it is right now, because at this point we don't really know whether that stalk label belongs to the small piece of the cake or the bigger piece. So how do we solve that? Well, we can simply do some small optimizations. By taking, for example, half of theta, so in this case half of 45 degrees, and using the same formula, we would get the label just where we want. But we can go even further. Let's say we want to have the stalks label closer to the center of the circle. Well, that's also easy. All we have to do is take half of the radius and keep the formula the same, and we get it right where we want it. Now there's still one issue we have to tackle, and that has to do with how in the scientific environment we talk about circles. Now if you try to program it yourself and use the built-in sine and cosine functions in Swift, you will notice a few issues. Because when you call sine of some degree, Swift is not expecting degrees. It is expecting the input to be of radians. And it's important that you understand the difference between degrees and radians. Well, we all know degrees. We describe a full circle as 360 degrees. Half of a circle is 180 degrees, and a quarter we describe as 90 degrees. Now, how does a radian differ? Well, we still have a circle, but in this case we start at the center and draw a line. Obviously this is going to be of length radius. Now we create an arc. It doesn't matter in which direction. It has to be of length radius as well. If we do that and then close the path, we have what is called 1 radian. And this unit is basically used to describe circles in most scientific environments. So to convert from degree to radians, it's not that hard because there is a mapping for it. So basically 90 degrees is the same as pi half, and a full circle is the same as 2 pi. So with that knowledge, we are ready to convert from degree to radian. All we have to know is that 1 radian is 360 degrees over 2 pi, which is the same as 180 degree over pi. And then we could define a function like this. To get the radian given a degree, we simply multiply the degree times pi over 180. Great, with this we're already at the end. Let's quickly conclude what we learned here. So first we learned that the path has this add_arc function that you can use on path, can be used to draw our pie chart. Then we also learned how to position the labels using some basic trigonometry. And lastly, we learned how to convert from degree to radian, because in the programming environment, we do not talk in terms of degrees, rather we talk in terms of radians. Now, believe it or not, this is all you have to know to draw pie charts. And in part 2 of the series, you will get straight into the programming. So I hope this was helpful. Make sure you subscribe to the channel so you get notified when the next part arrives, and I will see you in the next tutorial. Thank you for watching.